First half of lesson 10.2 is rational exponents. And you know, exponents are the little number above that says we're going to multiply this many times. And rational simply means it's a fraction. So rational exponents are those little exponents that are actually fractions. And it looks scary, so you look at all these and, oh, it's not that scary. It's not hard. You know how to do this. Here we go. What's going to happen is this. With the fraction, the numerator of your fraction becomes your exponent. The denominator becomes a root. Okay, so what this says is 36 to the 1/2 power is 36 to the square root. Okay, so the 1 is on here, but a 1 power is just itself, so we don't put that in there. And then a square root is this denominator of 2. Okay, so the bottom number tells you what size root you have. The top number tells you what your exponent on your base is. So this is just the square root of 36, and you happen to know that 6 times 6 is 36, so the square root of 36 is just 6. So 36 to 1/2 power is 6. Easy. Okay, so same type of thing. 81 to the 1/4 power is going to be 81. And it's going to be, the 4 becomes the root. The denominator becomes your root. So this is to the 4th power. And now this, if you'll remember, you can use your tree. 9 times 9 is 81. So 3 times 3 is 9, and 3 times 3 is 9. So there's a set of 1, 2, 3, 4 threes. And so we want the 4th root. So we want 4 threes. And so 3 is your final answer. Okay? Because there's a set of 4 threes, so we can bring it out of the box as just 3. All right, 125 to the 1/3 power, and now be careful where your parentheses are. These parentheses are around the whole thing, so that means the whole negative 125 is under the root box, and this is a 3rd root or a cube root. So now 125, well, let's see. What do you multiply together to get 125? We know that 5 times 5 times 25 is 125, and then 5 times 5 is 25. So now we have 1, 2, 3 5s is 125. And now remember, this is negative. So we could have negative 5 times negative 5 times negative 5 does equal negative 125, because 2 negatives make a positive, and that positive times a negative makes a negative, so that equals a negative 5. The square or the cube root of negative 125 is negative 5. Remember, if you have a cube root, if you have an odd root, then your negative can come out with it. If you have an even root, then your answer is can't do it. No real numbers. All right, in this case, now you're going to say, oh, we've got an even root, so that's not possible. But look, there's no parentheses around this. Anytime there's not parentheses around a base, the exponent is only on exactly what it touches. So this exponent only touches the 36, not the negative 36. So this is going to be a negative of a square root of 36. Okay, do you understand the difference between these two? If there's a parentheses around it, then the exponent is on the whole negative base. But if there are no parentheses, that means that the exponent is only on the positive base, and we want the negative of whatever we get when we take that square root. So in this case, because it's a square root, the 2 is the root. So now the square root of 36 is 6. And we want the opposite of that, so we want a negative 6. All right. X to the 1/5 power is going to be x under the box, and the 5 is the denominator, and the 5 is the root, so this is just the 5th root of x. And you have to just leave it. There's no way to simplify that any further. All right. A little bit more. Of course, we always add just a little bit more each time. 8 to the 2/3 power is going to be 8. And what happens with that numerator, remember, is the numerator becomes your power, becomes your exponent. So that's squared and taken the third root. So your numerator becomes your power, your denominator becomes your root. All right, so it's kind of like a circle, 8 to the 2/3. All right, so the denominator flips over and becomes your root. All right, so you can do this one of two ways. You can either square that 8 first and then take that answer and take the cube root of it. In this case, it actually is easier. We can take, it's the same thing as taking the cube root of 8 and squaring it. Either of those are the same. And in this case, because we know that the cube root of 8 is 2, it's actually easier to do this way first, because then we can say the cube root of 8 is 2, and I want to square it, so that's just 4. All right, so you could have taken 8 squared. 8 times 8 is 64, and then use your tree to find out what do you multiply together, and 4 times 4 times 4 is 64, and so you could have taken the cube root out of 4. So what I would suggest is first look to see, you can keep your number smaller. If you can take that root first and then multiply by the exponent, then that keeps your number smaller for working the numbers. All right, same type of thing here. Now with this, you've got negative 9 to the 5/2 power. Remember, this negative is not in parentheses, so it's not touching the exponent. So the negative has to stay outside, and I want 9 to the 5th power and the square root, the 2 here, but you don't have to put it if it's a square root. So now remember, I can either take 9 to the 5th power, whoo-wee, and then take the square root of that, or in this case, I can take the square root of 9 and then take that to the 5th power. Well, the square root of 9 is just 3, so I've got negative 3 to the 5th power, and I don't remember what that is. Negative 3 to the 5th power is 243, and it's still negative because this 5th power is touching the 3, not the negative. So you keep the negative all the way through. And this is just, you can either use your calculator and put 3 to the exponent of 5, or take 3 times 3 times 3 times 3 times 3. Either way is fine. Okay, same type of thing here. We're going to have the 1/9 to the 5/2 power. So the 1/9 is taken to the 5th power and then square root. Well, what we can do here is the square root of 1/9 is just 1 over 3, right? Because 1 over 3 times 1 over 3 is 1 over 9, and we can take that to the 5th power. And in this case, we still know that 3 to the 5th power is 243, so now we have 1 over 243. Okay, that makes sense? So the square root of 1/9 is 1/3. Okay, all right. X to the 2/3, we're going to do the same type of thing, except with now we have a variable. So this is just x to the 2/3 power. So the 2, the numerator becomes your exponent, the denominator becomes your root. All right, that's all you have to remember. Same thing here, 81 to the negative 1/2 power. Now here's the deal. If you have a negative power, what that means is I'm going to flip that to the denominator, okay? So the negative power flips it into, it's almost like we're dividing over and over again instead of multiplying over and over again. So that's why we put it down into the denominator. So 81 to the negative 1/2 power is the same as 1 over 81 to the 1/2 power. Now, do you notice when I flipped it into the denominator, I lost the negative, okay? Now it's in the denominator, so now we don't have to have the negative. We already dealt with the negative, okay? It went away. So now this is the same as 1 over the square root of 81. And I know that 9 times 9 is 81, so that is 1 over 9. All right. 16 to the negative 3/4 power. So first you're going to get rid of the negative power. So 1 over 16 to the 3/4 power. And now deal with your exponent. So we're going to have 16 to the 3/4 power. And then let's look to see if 16 is has a fourth root. That'll make our lives really easy. So 16 is 4 times 4, and 4 is 2 times 2. So I've got 4 2's. So this 16 has a fourth root, so what we can do is we can do that. Let's take 16 to the fourth root is 2. So now I have 1 over 2. This is worth 2. 16 to the fourth root is 2. And I'm going to take that cubed. So now I simply take 2 cubed is 8, and 1 over 8 is my final answer. Okay? All right. So it's what's happened. That's why I'm giving you tons and tons and tons of examples. It's the same type of thing, but there's just little quirky differences with each type of problem. So on this one, once again, we have a negative exponent. The negative exponent is going to flip it to the bottom of our fraction. This negative here, remember, it's not attached. So we're just going to you can kind of just leave it alone until the very end to remember, okay, the whole thing is negative, but don't lose it along the way, okay? Don't lose that negative. So kind of stick it out there so that you don't forget it, and then you've got 1 over 27 to the 2/3, and that gets rid of your negative exponent. And now you remember, what do you do from here? Remember, you've got the 2 is your exponent, the 3 is your root. So negative, don't lose the negative, 1 over 27 to the 2/3 power. And I still like to look to see, does 27 have a cube root? Well, 27 is 3 times 3. 27 is 3 times 9, and 9 is 3 times 3. So 3 to the 3rd power is 27. So this is 3 times 3 times 3. So I took all 3 out, and so I get, don't lose your negative, 1 over 3 squared. All right? So this 27 to the 3rd power comes out just as a 3 because I have a set of 3's under there. So that becomes just 3. And don't lose your squared. Now 3 squared is 3 times 3, so it's a negative 1 over 9. Okay? All right. What happens if we use the same problem, but I want this negative 27, I want the whole thing to be to the negative 2/3 power? Okay? We can do that too. Let's see how it changes it. Sometimes it'll change it and sometimes it won't. It depends on the numbers. So in this case, the whole thing is going to be taken to the negative 2/3 power. So negative 2/3, let's get rid of the negative exponent. We're going to flip it to the bottom of our fraction. So 1 over negative 27 to the 2/3 power. So far, so good? And now we're going to say, keep it under 1. And this is going to be negative 27 with a root of 3. Up, and this is the 2 to the 2/3 power. 2 is your exponent. 3 is your your root. Here we go. All right, we can do this. We can do this. All right, so now the same type of thing. So 3 times 3 times 3 is still 27. But in this case, negative 3 times negative 3 times negative 3 is negative 27, because an odd number of negatives gets you back to a negative. So this is going to be 1 over negative 3 squared. And now remember, you've got to keep that the parentheses around it because that keeps the whole negative 3. Now we're going to square it. Okay, it's not just the 3 that's squared, it's the whole negative 3. So now negative 3 squared is negative 3 times negative 3, which is a positive 9. So your answer is 1/9. So in this case, you've got a positive 1/9 when we started out with a negative 27 to the negative 2/3 power. And in this case, if we're going to take the opposite of 27 to the negative 2/3 power, we actually end up with negative 1/9. Okay? All right. One more set, just a few more problems. You can do this. Hang in there. This is dealing with problems that are just have the variables. All right. So in this case, this is going backwards. With all of these, they gave us the fraction exponent, the rational exponent. Now what I'm going to give you is I'm going to give you a root, and I want you to change that root to a rational exponent. Okay, so I want you to go back and forth between the two. So in this case, you've got x is your base, and 3/4 is your fraction. So don't forget, the numerator is your power, the denominator is your root. Okay, so in this case, you've got 1 over x to the 2/3, right? 2/3. And so if you've got it in the denominator, you can say this is x to the negative 2/3 and undo one of these. All right? In this case, remember that if the exponent is under the root, it's the same thing as if it was on the whole thing. So this is t to the 3/5 power. And this is going to be 6 over x to the 4/5 power. But now this x to the 4/5 is in the denominator. Let's put it in the numerator. Let's keep everything in the numerator. So the 6 stays in the numerator, and then x to the negative 4/5 brings it up into the numerator. All right? That's a lot of stuff. I think you can do it though. There's a lot of little piddly stuff. Be sure to ask lots of questions in class, and I'll see you soon.